want to pick up in section 8.1, and I'm on page 411. You've already watched 2 videos, and now I want to continue what you were seeing and learning in the videos on this page 411 and read a couple of things to you. Nothing is proved absolutely. With what we're about to do called hypothesis testing, keep in mind that nothing is proved absolutely. Likewise, the decision to reject or not reject. This is probably unfamiliar terminology to you, but we've got to learn it. We've got to walk in it, absorb it, that there are going to be these phrases called that we will reject or not reject the null hypothesis. It doesn't prove a thing. The only way to prove anything statistically is to use the entire population, which in most cases, it's not possible. So then the question is, how large a difference is necessary to reject the null hypothesis? And here is where we're going to bring back your level of significance. We've already played around with them. You need to make sure you've got out your formula cards, some sticky notes, highlighters, pens, paper, lots of note paper, because we're still working on like we are in class. They mention a level of significance. It's the maximum probability of committing a type 1 error, which is what you just heard in the other video, and this probability is symbolized by alpha. That is, the probability of committing a type 1 error is alpha. The probability of a type 2 error is beta. Just so you, alpha we've already played around with, looks like a little fish, and beta looks like a bee with a tail. In most hypothesis testing situations, beta cannot easily be computed. However, alpha and beta are related in that decreasing one increases the other. Statisticians generally agree on using 3 arbitrary significance levels: 0.10, 0.05, and 0.01 levels. I want to point you to your charts. And when you look at your charts, I'm looking specifically at table F. And when I look at table F, you'll see many of these. But notice they're already related to the ones that we've already been talking about on confidence intervals. And notice they're calling them here levels of significance. Keep that in mind, and we'll be coming back to our formula pages. So it says those are the levels, and that is if the null hypothesis is rejected, the probability of a type 1 error, remember that's alpha, will be 10, 5, or 1%. And even notice up here they've got alpha. That is, if the null hypothesis is rejected, the probability of a type 1 error will be these as you see here. Here's another way of putting it. When alpha is 0.10, it's 10%. There's a 10% chance of rejecting a true null hypothesis. When alpha is 0.05, it's 5%, and when it's 0.01, it's 99. Well, it's 1%. It's related to 99%. This one will be related to 95, and this one's going to be related to 90%. I'm going to go on over to page 412. This is a critical, and it's not going to be a pun on the words we're about to look at or a play on those words. This is really critical that everything that we're talking about, you start and stop this video as much as you need to make it make sense, to soak it up. Go to some of your favorite sites on some websites that help explain this maybe better for you. You have got to fully understand each one of these ideas, because when we put them all together, it's a pretty long process to do this hypothesis testing. So part of the understanding is that there are going to be 3 definitions: a critical, a non-critical, those are regions, critical region and non-critical region, and then a critical value. The critical is going to be, if we land in that, we're going to reject. If we land in the non-critical, we're not going to reject. And there's going to be a value that separates the two. Keep in mind, we have critical, non-critical, and then a critical value. Down about halfway down on page 412, here's a one-tailed test. These words should sound very familiar. One-tailed, which can be right-tailed or left-tailed. And so, you see my little note to myself, show the pictures. Do you see here how here is a right-tailed test? See where they've got the critical region is over on the right-tailed side. All of this region over here is the non-critical region. And then this value, oh look, it's a Z. that is going to be that critical value. If you look on over at the top of page 413, it's showing one, well, and it actually said critical and non-critical in this one. Down here, you'll notice we have a left-tailed, and you'll see the critical region, and that's our little 1%. And then the non-critical region is going to be the rest, which will be 99%, and we have a critical value. I'm not going to show you the chart yet. I'm going to keep going right here. If we have a two-tailed test, it's going to be something a little bit the same and a little bit different. And if you look down here at the bottom, it says we're spreading 99 across this 99%, but notice this is just going to be half of that and half of that. In other words, half of a percent, half of a percent. Because up here, we were talking about a 99%, and we got all the 1% over here. Well, if we're still talking about a 99%, we just have 1% over here, and we have our full 100. But remember, we've been doing some stuff with z sub alpha over 2, and where we had our 99%, that means we've only got 1% to share, so we have to put it over 2. We have to cut it in half, so we don't get 1% and 1%. We get half of that, half of a percent and half. I'm going to keep looking over here. This is where I want to pull out the formula card. So I'm on page 417, and when you're looking with me on page 417, I need you to highlight, circle, underline. I got a whole lot going on here, but I like to pull table F. And sometimes it'll mention go to table E or go table whatever. I like table F because it has one tail, two tail, and it's talking about alpha. And it has these percentages, either the 10%, the 5%. And if this is one tail, it gets the whole 10%, either on the left or the right side. But if we move to two tail, it had to have been a 20% to get cut down to the 10%. All of this is going to go together and work together to be somewhat similar. Here's a 1%, 1%, 5%, 5%, 10%, 10%. And then I'm going to go all the way to the bottom of this chart. Because when you're talking about t-distribution, when you go to infinity and beyond, we're going to end up with these same numbers that I saw one student had written on their page, on their formula card a while back. I had said take these numbers for 90% and write them down. It's going to be your z sub alpha divided by 2. And so this is going to help you to keep straight. Looking here, am I a one tail or two tail? Do I use it all? Do I cut it in half? What's going on? So keep in mind what they're looking at here is if we have our null hypothesis, and let's say we're looking at an alpha of 10 and it's a one tail. And notice here it's an alpha of 10 and we're one tail. You got to keep pretty much two main, probably 3, 4, 5 things, but two main things in mind. If I'm looking at the tail that's the left tail, I'm to the left of my mean, I will use a critical value that's a negative. If I'm over here on the right side of the mean or the middle, then I'm going to use a positive value for my critical value. And I'm going to use this chart, and let's just play with one. It's not going to do pluses or minuses, so I'm going to stick with the positive one for right now. It's a one tail, and with it being one tail, and I want to go to 10%, then I'm going to go up here to one tail. I'm going to go to 10%. I'm going to go to the bottom, and it says I use 1.28. And when I look right here, lo and behold, they used 1.28. But for this 10%, they used a negative. Yep, it's on the left side, and you've got to just remember, when it's over here, I use a negative. When it's over here, I use a positive. I want to play with one of the two tails. A two tail, oh look, it's a 10% again. So I just go use this same number I used up here, right? Wrong. Down here, I'm at 10%, but with it being two-tailed, it's split. So it's really 5 and 5. But it takes care of it here. If we remember I'm two-tail, I'm going to a 10. Two-tail, whoop, two-tail. It's a 90%. I'm looking at a 10% alpha. And if I scroll all the way down to the bottom, pull my finger down to the bottom, it's a 1.65. And if you look right here, look there. It says plus or minus because the one on the left is going to be our negative 1.65, and over here will be the positive 1.65. So, make sure you're stopping, thinking. I've got several more things to show you. Looking right here, It says here's going to be a procedure table. We cannot shortcut this. We've got to do these things like we've got to draw the figure. And you saw in the last test how actually part of the question was draw. Well, we're going to be doing that again. Draw. We're going to draw, and it's going to talk about if it's left tail, do this. If it's right tail, blah, blah, blah. Over here, if it's not if, it's a step 2. And it's going to give us some more stuff that says, I don't know why it's so blurry tonight. But it says if it's a left tail, we're going to do one thing, and it says something about table E, and I'm talking to you about going to table F, and I like table F better. And you will find which one you like. Like the student who showed me they had it written, I think they had it written at the bottom of table E. Well, yay, use table E. That sounds great. I like table F. So let's do a couple of examples, kind of like maybe one. And so on this one it says using table E, and I'm going to table F. Find the critical values for each of the situations and draw the appropriate figure showing the critical region. So they're saying let's do a left tail with an alpha of 10. Remember, left tail, you get it all. Right tail, you get it all. A two tail, we're going to have to split the information. So starting with left tail, it says draw a picture. I scribbled out a picture up here. I got my left tail. I got the 10% over here, 90% over here. So the question is, what is that critical value? When I look down here, it mentioned, let me go back up here. With it being a 10, that's a 90%, or 10, and it's a one tail. And so I'm going to go to table F. And when I go to table F, I'm going to go to my one tail. And I'm looking here at my 10%. And when I look at my 10%, boy, it can be confusing. 80? No, yes, no. 10%, one tail. When I go down to the very bottom, it says I'm a 1.28. When I look right here, it's like, oh, not a 1.28. That's on the left side, so it's a negative. I'm going to leave these other two for you to look at. The other two, you will draw. You will play around that they want to do a two-tailed with a 0.02, which relates to 98%. And then they want you to draw a right-tailed, which relates to 0.005. Ah, that's relating over there to that 99%. I'm going to keep going because I'm trying to keep the video manageable. And you are going to do B and C. And so C is at the top of 417. B is at the bottom of 415. And then we'll go right here, get your highlighters, a lot of stuff going on. In hypothesis testing, the following steps are recommended. Big, fat, but, ... Right down here. For the purposes of this chapter, a simplified version of the hypothesis testing process will be used. That's us. Since designing the study and collecting the data will be omitted, the steps are summarized right here. You also might go take a gander at your formula card. And if you flip around on your formula card, you're going to find a page that has this, and it has this. Notice this one says traditional, and this one says P. All of us statistics teachers have gotten together. We are not teaching P. We're teaching traditional. And so when you look right here, it says procedure table, state the hypotheses. Guess what the first thing is over here? State the hypotheses. Identify the claim. Identify the claim, and so on. Find the critical values. Oh, that's what we were just playing with. Then compute a test value. We're going to get into that. What is that? What does that mean? And then make a decision based on your test value. Am I going to reject or not reject? And then I have to write a sentence. This is a pretty huge process that if you really practice, it will become ingrained, and you're going to have it, and it's going to work, and it's going to be fine. Notice I got a lot of scribbles because we're not doing p-value. So right here, the top of 417, you might want to put on some blank part of this formula card. You may want to put it very close to your procedure table. You may not. You may want to put it on one of the blank parts of your formula card. But this table, again, no play on words, it is critical. It's going to get pretty involved with what we're doing. Like, do we reject? Do we not reject? Oh, wait, which one was the claim? Oh, when you say this, if it's the claim, or do I say that? Oh, I don't know. I would write this entire table somewhere on your formula card. 4 parts. Reject the null. Do not reject the null. But what was the claim? Was the claim the null? Was the claim the hypothesis? Which one? Null, alternative. Well, based on what our decision is, it's going to be based on what we write. We'll write one of these 4 things. I'm going to read through all of these paragraphs. And this is definitely a spot you may want to go ahead and pause, think, soak. This is the end of this recording when I get through reading these paragraphs here. To further illustrate, the claim can be either the null or the alternative, and one should identify which it is. After the study is completed, the null hypothesis is either rejected or not rejected. We don't say true or false. And we'll say that down here. We don't say it's yes. Anyway, right back up here. From these 2 facts, the decision can be identified in the appropriate block. For example, suppose a researcher claims that the mean weight of an adult animal of a particular species is 42 pounds. We've already gone through, you've already looked at videos, how you go ahead and write that the null hypothesis is 42. There it is right there. In this case, the claim would be that the null hypothesis, that is our claim. So up here, the claim is the null hypothesis. So I'm going to cover this part up. If we reject the null, then we write this. If we don't reject, then we write this as our conclusion. You don't have to go creating words. You can just pull these words right here and fill in the pieces of your particular example. So looking right here, if the null hypothesis is rejected, okay, well, right here, let me use a sticky note. If the claim was the null and we do reject it, we're going to state this block right here. There is enough evidence to reject the claim. I'm already confused. If it is rejected, the conclusion would be that there is enough evidence. Do y'all see the words up here in this block? And how we will use the words, there is enough evidence to reject the claim that, and this is where we fill in the data information specific to whatever problem we're dealing with. And you'll just go pull words out of the problem. You don't have to create those either. Of the adult animal, that it is 42 pounds. I'm going to do this one more time. On the other hand, suppose the researcher claims that the weight of the adult is not 42 pounds. And if it's not, then the claim falls into the alternative. So let's see if I can get enough little piece of paper right here. Then in the second example, they're saying that the claim is the alternative. So the claim is the alternative hypothesis. And then furthermore, suppose that the null was rejected. And so if the claim is the null and we actually reject, then this again, not again, but the top box is the one we use, that there is enough evidence to support this claim. And you'll see right here, the conclusion then would be that there is, suppose it is not rejected. I'm sorry, I read rejected. Cross this one off. If it's not rejected, we did not reject it, and it's going to be this one. There is not enough evidence to support the claim, which is what they're stating right here. Then the conclusion would be that there is not enough evidence to support the claim, and then you fill in the words from the problem that the animal is not 42 pounds. Whew, I hope you started and stopped on this piece. And I hope that you've written this on your formula card, and I'll finish this up and say, again, remember, nothing is being proved true or false. The statistician is only stating that there is or is not enough evidence to say that a claim is probably true or false. And as noted, the only way to prove something would be to use the entire population under the study, and usually this cannot be done, especially when the population is large. We are finished with 8.1, and I'm finished with this video.